So I've already had a few questions during office hours. I've got a few I want to do. I'm going to ask myself these questions for you. But the very first thing I want to announce, I might have to announce this a few times. I ran this by a few people and it crowd tested really well. So what I'm going to do, actually it didn't matter what they thought I was going to do either. The quiz that's scheduled for tomorrow, I'm going to move it one day forward. It's going to be on Thursday now. Yay! I have no idea how you feel about that. And I'm going to try to catch up more with the homework. I feel like I'm a little behind in grading homework. I'm almost up to date in my other two classes, and you're my last class of the day, so I think I just do them in order. So now I'm a little behind with this class. So we'll make that official. The quiz will now be on Thursday. Okay. And the crowd goes, it's fine. Let me think what else. There was something else I want to say. As I'm thinking, anybody have questions from homework stuff? There should be questions from homework stuff. I'll tell you that right now. Okay, I'm going to ask some questions for you. Let me see, where was I? How about I ask this question? Hey, Jeff, can you do another example of graphing a piecewise function? You don't have to tell me this, but I'm almost certain that you're like, yeah, that sounds like a good idea. But see, you could have asked that question and I would have done it. It's amazing how that works. I'm sorry, I'm being so, I'm your real jackass right now. But trust me, if you have a question, at least 10 other people have the same question. There's no reason to not ask it. So as I catch up in homework, I'm realizing, oh crap, I better do some of these. Yes.
I have one. 3.7, number 12. I couldn't remember what number it was. That's the function with the 2x plus 3 over 5x minus plus 4.
Oh, good. Okay, that's another one I want to do. I think it was you I promised I was going to do that kind of problem. All right, let me see. So Jason, correct me if I'm wrong. I'm not going to do exactly that problem, but it's something like this, right?
Yeah, except for the signs are the same, top and bottom, but I don't know if that makes a difference.
Not really.
Okay.
All right. And then the problem is to find the inverse, right?
Correct.
Okay. So there was a very similar problem in an earlier section of homework that was just really asking you if it was a function. So you had to solve for x because it had y's here and it had x here. So that's basically what we're going to do, of course. What is my first step? Oh, did I start recording? I did. What is my first step towards finding the inverse?
Wouldn't you multiply 3x plus 5 to both sides?
Nope. Not yet.
You're going to swap the x and y.
Signs.
Yes.
Yes, the x, y. I like it. Then I'm going to do what you said. So I'll go ahead and do that. I'm going to multiply this up. Now, and this is about where everybody freaks the shit out, right? Let me do this real quick. I need to spotlight myself. Ooh, look at me. And, part of me doesn't blame you, but the rest of me does. So it's, you know how to solve when you have more than one of the variable you're solving for. I'm trying to solve for y, right? You know how to solve. You get them all on one side. And everything that doesn't have a y, you get them on the other side, right? We know this shit. So does this have a y? No, get out of here. Does it have a y? Yeah, come over here. So I'm going to subtract 4y, and I'm going to subtract 5x. Because now, what can I do here?
You can factor out the y.
Yeah, so there really isn't two y's. There's one that's been distributed. You just have to get them all together so you can undistribute it. One y. And then you can just divide. So you get the inverse will be 5x, negative 5x minus 1 over 3x minus 1. Yeah. All right, so that relates to another problem that was earlier in the homework. I can't remember where. That's the step right there that freaks people out. If you add 1 and divide by 4, you have not solved for y. And you know you haven't. You haven't solved for it if it's still on both sides of the equation. You know that, but I know that your brain goes, I don't know what else to do, man. This is not something we do a lot of, so I really don't blame you a lot for forgetting how to do this. Right? I understand. Okay.
So all you did was switch the 4 and the 5?
Huh?
Negative 5.
Oh, so what's really interesting is it's not quite that simple in general. There's a few things that happened. In fact, what's really interesting, it sounds like you might be interested in, I don't know if I could do this and everybody would suffer with me, but if you do the same thing we just did with this, you can figure out the pattern that you're trying to figure out right now. The problem is you're trying to figure out a pattern from one example. No, you never can figure out a pattern from one example, ever. But if I do this, now I'm going to have an example of every possible type of thing that looks like this. Because what could A and B and C be? Anything. So if you do what we just did with this, you'll know how to do any of these kind of functions. Because you'll know how it switches. So you could probably guess that these do switch places, right? Just like they did. But then there's something to do with changing the signs also. I'm not going to tell you what it is. And what's really interesting is, how many of you guys have ever done matrices? Have you worked with matrix algebra? Have you looked at something called the inverse of the matrix? If not, it's okay. It's in our future, though. It's in our future. And when we get there, I'm going to remind you of this. Because it's going to be the same.
It's the
pattern.
same thing. It's the same thing. It's the same thing with the brackets, but with the negative 1 on the outside.
Oh, sure. Yeah, the symbol for doing the actual inverse. Yes, but
Yeah.
I'm talking about the actual process of doing the inverse. Anyway, that's enough of that one. Anybody have any other specific ones before I do the piecewise example?
Oh yeah, I have a question about the piecewise.
Well, let me turn this down. Sorry. I cranked up my AC. I just realized that's why I'm yelling like crazy. Plus, I destroyed my knee going running yesterday. That was awesome. So I'm like hobbling around. Yay. I'm sorry. Who's asking something? Go ahead. Sorry.
Never mind, I figured it out.
I still can't hear you. Let's see.
I said never mind, I figured it out.
Oh, okay. I like it. Such a great way of teaching. Just get busy doing other things until the students figure it out themselves. I love it. All right. Anything else specific before I launch into a few things, starting with piecewise functions? Okay. I don't see anything. So let me ask you this real quick. If somebody said they graphed a piecewise function and the graph looks like this, what can you immediately tell them?
It's not a function.
Yeah, so what must they have done? They must have made a mistake, right? So if the problem is claiming that it's a function, you know you shouldn't have that situation happen, right? So that's a mistake. And that's a very glaring mistake. So you should know something went wrong. What I don't quite get when I see these problems is, all right, let me see. Let's see. All right. I don't know if people really understand this. How many functions have I just written up on the board?
2. No.
No.
1.
1.
How many parts does that function have?
2.
Yes, there you go. This is one function. So if I ask you to graph this, you better not have multiple graphs. That makes no sense. This is one function. It gets one graph. Is everybody with me? I like it. And even if the function is simple, if you're not comfortable with piecewise, make a little table. So you know, for this table, for 2x minus 3, I'm going to only use x is less than 3. So why am I going to do this immediately? I just said I have to use x is less than 3. Why am I going to do that? I got to know where to put the open circle, exactly. I don't know why I'm doing this. I'm not Italian. I'm a redneck. I'm a non-practicing redneck. Anyway, that's a whole story. So if I plug a 3 in, this is why I do this. This is my own notation. I just do that to remind myself that's an open circle. So when I put a 3 in, I get remarkably enough. Thanks for that. And when I put a 2 in, I get 1. And when I put a 1 in, I get -1. And that's enough, because I know it's a line, but it's just always nice to have a little plot. And then for this guy, I can start at 3 and go up. So 3 squared 9 minus 11 is -2. 4 squared 16 minus 11 is 5. 5 squared 25 minus 11 is 14. I might not even use that point. I don't care. So, the other side of this problem, let me finish this up and then I'll show you the other mistake people make. So now when I go to graph this, I don't even know if the different colors show up really. Does that look like purple to you? No, it just looks like, okay, whatever. When I go to graph this, good. Oh my God, this is so exciting. All right, X, Y, yeah! So 3, 3 is an open circle, 3, 3. Oh God, let me see. I gotta look at the, screw that. All right, 3, 3 is roughly there, I think. Does that look all right? Almost, okay. It's so weird from my perspective. All right, that should be good. Yes, okay. 3, 3, and then 2, 1. And then 1, -1. It's supposed to be a straight line? What the shit? Oh, why is it over 4 now? All right, Jeff. Good Lord, dude. That's a little bit better. Still bad. Just make them big. All right. And it keeps going that way because it's for less than 3, so it's going to go that way. And then this guy, 3, -2, 4, 5. And then it's parabolic, right? Parabolic, so I can just connect those. Make that big. Okay. This is why you should invest in graphing. Anyway, the big thing to realize there is even if it's a simple function, you might want to do this for yourself. It just makes you feel a little better to have anchors. See how you do not overlap. What is the domain of this function?
-infinity to infinity.
Yes, I love it because you wouldn't exclude this because there's the output. 3 has an output. So the domain is going to be -infinity. I like it. Okay, maybe. So you can do every single, and the ones that have 3 parts, you'll have 3 tables. Okay, maybe. So here's the other mistake people make. Has everybody got what they want from this mess up here?
Yep. We're good.
Okay, wait. Who's somebody? Oh, somebody's clapping your hand. Okay, whatever. All right. So here's the other mistake I see from this. Imagine you're a math teacher, and for this problem, you get this answer. Where was I at? What answer, Jeff? Be quiet. I'm trying to do it. And that's it. That's your answer. That's it. There you go, Jeff. All right. What is this missing? I appreciate that they know what things look like. That's nice. But what's missing? Work?
Arrows.
Arrows, good. Arrows are always nice. And work?
The
Arrows.
value.
Scale. Yes, scale. Holy shit. I like it. So we will eventually be using, in fact, today I'm going to show you how to use the graphing calculator. I think I already did. How to use it to find maxes and mins. I'm pretty sure I did, but we got to do it again. So we will be using a graphing calculator for a decent amount of things, but one thing you got to know about me is we will never stop doing things by hand ever. We will start doing a few more things in the calculator, but we will never stop doing them by hand because that means you learn. Calculator, you know buttons. And then my standard joke is the calculator passes the class, it goes on, gets a wife, has a great life, and you're retaking the class. Good job. All right. Anything else about piecewise functions while I'm still talking about them? Any specific questions or general questions about piecewise functions?
I have a question. I don't know if it's about piecewise, but it's question 60 on 4.2. No, 3.2.
60 on 3.2?
Yeah.
All right, let me see. All right, here we go. Shua! All right, so this is the one that, yeah, excellent. See, I mean, this is a great question because it's a freaky ass question. What better question than that? This is the one about the height of a projectile is a function of the time it's in the air. Ooh, that's a very, very, very important phrase that I just said. The time it is in the air. Let me share the screen here in case you don't have the access to the book. So we're talking about this problem right here. Hopefully this looks familiar to everybody considering this is section 3.2. We should probably be a little bit farther than that with the homework. So here's the height function. What's the domain of the function? So the problem, you can't look at this function and figure out its domain as a function standing by itself because that's not what it is. It's representing something in real life. Will that projectile be up in the air for eternity? No, it doesn't have escape velocity. But also, you know that this is a down parabola. You know that, right? Because the t squared has a negative coefficient. So it's going to come back to Earth. So there's no way your domain can go to infinity, right? It will come back to Earth at some point. And so you got to figure out, when does it come back to Earth? How do you figure that out? What would H be if it has come back to Earth?
0.
0. I love it. So solve 0 equals that, and you'll actually figure out the t values that make sense for this function. Does that help everybody? Because I had a lot of people say 0 to infinity, which is wrong in a few different ways because, again, this is a down parabola. So it's going to hit the x-axis again. Yeah, anyway, you get the idea, hopefully. Okay, is that all right? I'm not trying to make anybody feel bad. Don't get me wrong, but you got to start to realize when we have a problem that's not purely mathematical, it represents something in the real world. You need to step back outside of math and just think about what the situation is. Some of you guys get a little too focused on the math, which normally I'm like, oh, that's amazing, that's cool, but In this case, not quite so cool. It's got to be tempered by what makes physical sense. So when that thing hits the ground, does that function mean shit anymore? What's it going to do when it hits the ground? It's going to stop, or it's going to bounce. I don't know what is this? Does it tell me? It's a projectile. It could be anything. Maybe it'll bounce. Maybe it'll explode. In which case, it then needs a ton of different functions for all of its little pieces that go flying off in their own trajectories. All right, I went a little too far. I'm sorry. I'll stop.
So the idea would be that when, I guess, height equals 0, then the function would stop working.
Beautiful, because then it won't continue on that trajectory. So if I throw a ball up here after 1 second, and it's going to come back down after 9 seconds, there's a nice function for this. There's a function for us. Does it continue after 9? Well, no, unless you threw some kind of weird tunneling device. So no. Right? It's going to stop. The function is going to stop meaning anything there. So this is a different, I want you to realize, this is a different reason that a domain could be cut off. This is a physical reality cutting off of the domain. When does that function stop making sense for the trajectory of this thing? Well, when it hits the ground. And also, did it make any sense going back in time? No. Right? I wasn't 6 feet under several seconds before I threw the ball. I mean, that's I don't even want to go. My head's going in all kind of horror movie directions. Zombies throwing balls with the shit. All right. Are you guys understanding? So when the problem is dealing with a physical situation, you do have to slow your roll a little bit. You can't just start attacking it like a normal mathematical function because it's got extra things it's got to live up to. It's got to make sense in the real world. Okay. Yes. You're so soft. Are you talking to me?
And then
Sorry.
you take out the GCS.
Is somebody talking to me? Sorry.
It's just lagging. Her voice is low.
Yeah. And also very soft.
Yeah.
Are you okay out there? Is this Athena or is this somebody else?
Yeah.
Who is this?
Yeah, it's Athena. Can you hear me?
Yes, now I can.
Okay. So I said when you set it equal to 0, then you take out the GCF, which is 16t. What do you
Sure.
do after that? I'm confused.
Well, I mean, so now that is a purely mathematical thing. And if I've got 8t times 4 minus t equals 0, for example, what would you do next?
You set each one of them to 0, 8t to 0.
If I got this number times this number is 0, then one of them have to be 0. That's why that number has to be, if that number was anything except 0, I couldn't do shit. If that number was 16, does either one of these have to be 16? No, one could be 2, one could be 8. One could be 16, one could be 1. One could be 32, one could be a half. There's an infinite number of shit that could be. If it's 0, one of them's got to be 0. So now we get t equals 0 and t equals 4. That's not the answer, though. It's a different problem. Okay. Is that all right?
But then you get t equals -6, and how do you have negative time?
You definitely don't get t equal -6 because when you take a negative 16 out, the 96 becomes negative, the result. Right?
Oh, okay, yeah.
Otherwise, I'd agree with you. That would be weird. Now we're talking about time travel, which in general is a good topic with me, but and this problem, no. Okay. Especially considering Bill and Ted's new thing came out. No phone booths required for this math. All right, that's enough of that one. Anybody have any other specific questions before I go back to my list of things I'm asking for you? No, okay, so something else that's driving me a little bit crazy. Let me do this problem here. Can you guys see this problem here? The upside down parabola?
Yes.
Yes, thank you. The domain, in this specific problem, where does the domain start?
-3.
-3.
Yeah, so when I'm talking about domain, my answer is only going to be x values. That's it. So the domain, it starts at -3. If that was an arrow instead, then where would the domain have started?
-infinity.
Good, because the arrow keeps in that fashion. You could find an output for any x. Keep going down that way. But it stops right there. So it starts at -3. And of course, it stops at
2.
2. What's going to be on the 2 when you write it interval notation?
Parentheses.
Parenthesis, because you can't allow it to be 2. There's no output for 2. And then the range, you do the same thing I just did. You just do it on the y-axis. Right? So the first place I see it is -5, and the last place I see it is 4. Will I include the 4? Why didn't I include the 2? Because there's a...
Open circle.
Is there an open circle here?
No.
Nope. So of course I include the 4. 4 is an output. When x is 0, 4 comes out. That's an output. So that's going to be a part of the range. Is that all right? So there's just a few people that are getting that kind of mixed up. Your brain, when you're talking about domain, you start looking at these numbers. Never. Domain is all about x's. That's all they are. Range is all about y's. All right. Let me see what other thing I wanted to talk about. Oh, man. Ouch. 3.3 had some issues. Let me see. Oh yeah, this is all about, okay, this is nothing wrong with this. Oh yeah, we really love this. I'm gonna ask a question for you. I'm gonna ask, where was it? Was it in here? Yes, it was number 12. Does number 12 look familiar to anybody? Is number 12 anybody's nemesis? I don't know. Okay. All
Yeah.
right. Okay.
I had a problem.
Gotcha. I understand. So let me do it up on the board. Let me stop sharing. If you want to, I'm not going to do 12. I'm going to do 11. Because 12 is your work. I ain't going to do that shit. So I'm going to do number 11, 1 over t plus 4. I'll write it up on the board. Oh, God, Jeff. All right. That's the one thing about my place. I got to figure out how to give myself some room. All right. So I think it was, where'd it go? Yeah. A of t is 1 over t plus 4. And I want to know the average rate of change there. So one thing that a lot of students appreciate, and I do too, not always though, but is like a general format for an idea. In mathematics, there's an idea, and you apply that idea the same way, but the stuff you're using in the idea might make the work harder. What the shit am I talking about? Well, the idea for average rate of change, I'm going to use this function's name, would be a of x2 minus a of x1 over x2 minus x1. So I really appreciate that some of you guys are realize that that's a lot of shit to worry about all at once. So you broke it down. This is beautiful. So if you do a of 9 plus h, right, that's x2. That's the second x point. What is a of 9 plus h?
One.
9 plus h plus 4, which would be what? 11 plus h?
Yeah, so 9 plus h plus 4, so that'll be t, gather t, h plus 13, right? Holy crap and a half, Jeff. Can you write? Let's try it. Oh, look at you go. Right, so you put a 9 plus h there. 9 and 4 is 13. Bam. And then, of course, what's a of 9? Well, that's just going to not have an h, right? 9 plus 4, so that's 1/13. Let me stop for a minute. I wrote down the idea of what it's asking me for, and now I'm going to start filling in the stuff. This idea never changes. I just wrote it in terms of A. I could have put an F there for more general stuff. And then, so on the top is going to go this bad boy, 1 over h plus 13, minus the other one, 1/13, all over x2 minus x1, 9 plus h minus 9. Become a normal 9. What's normal? Shut up. All right. Maybe. Here's where people trip up. Well, the people that made it this far, they get a little confused about what to do here. Why? Can you understand the optimism of somebody that would do something like this? And if you did that, I am not picking on you. I am picking on everybody who did that because you're not alone. So why is that wrong? You can see the idea, right? You can't fault them. They got the basic idea. The freaking bottoms have to be the same, don't they? Before I can combine those bad boys. But are you allowed to add the same thing to the top and bottom of a fraction?
No.
Yeah.
Oh, no. Otherwise, 1/2 would equal 2/3. For that matter, 1/2 would equal 0. Because you subtract 1 from the top and bottom, you get 0. So if I owe anybody $500,000, I owe you 0. Oh, doesn't work. I've tried it. Doesn't work. So no. What's the only thing you're allowed to do to the top and bottom of a fraction?
Multiply.
Multiply your butt. So we're going to multiply. So this guy has an h plus 13. Let me see if you guys think I'm insane when I say this. This guy does not have a 13 on the bottom. It's okay if you think I'm insane, because it's always possible that I've gone insane. That's why it's better probably that we're not in the same room. You never, Jeff has gone insane. Does everybody understand what I mean by that? This does not have a 13. It doesn't. It has an h plus 13. I don't know what the shit that is. And this guy's got a 13. So, of course, what's he missing?
13.
13. So you got to multiply him by 13. And then what's he missing?
H plus 13.
H plus 13. I love it. I didn't see any evidence of this, but is anybody freaked out that I'm not doing anything with this down here yet? All of this.
I'm following you now. I said I was at first, but I'm following you now.
Yeah, everything I'm doing only has to do with these two fractions. What I'm doing right now has nothing to do with this guy at all. He doesn't have to be involved. There's no reason. Now, of course, I can simplify the bottom, right? So let's see what we get. On the bottom, I'll do the bottom. Whew. Okay, that's hard. And then on the top, I'm going to get 13. Let me see if you guys can do this right. 13 minus what? Exactly how would I write it?
H plus 13 in parentheses.
Okay, good. So, and then if you distribute the negative, you get that. So minus h minus 13. That's another place people can make a mistake. And on the bottom, I get 13h plus 13. So how does this come out? So then I get negative h over 13h plus 13 over h. And I'm getting right to the bottom of our viewing ability. Let me ask you guys a question. What is 9/4 divided by 9? Not a lot of work intended here.
1/4.
1/4.
Yeah. What's 9x divided by 9? X, right? What's 9a divided by 9? A. So what's Negative h of these divided by h.
-1.
Yes. Or you could rewrite this as times 1 over h, and the h's cancel. Or you could just freaking realize the h's freaking cancel.
Because can't you apply division in any order like that? I think.
You got to be careful because this is the interior fraction here, and this is the bottom of that fraction. I mean, you see what I'm saying? So you can't like make this the big one and this the small one. That'll actually alter the order of operations. I'm not sure if that's what you're asking. It's sort of like, what is h being divided by? This and this. It's being divided by both of those things.
Yeah. Okay.
So your answer for that other problem that you have to do for homework should look a lot like this at the end. Okay, all right. And again, this is kind of stuff that we don't really do a lot of, so I don't fault you that much for not knowing. I fault the hell out of you for not asking, right? You gotta ask. And I hope you understand that if you ask me in the homework you do, I don't have all the time in the world to answer it there. I'd rather have a wider audience to hear the answer. So I'd rather you ask here. And if you're very shy, you can just chat to me directly, privately, a question. And I won't call you out. I'll just answer it, right? Somebody need that up here still? All right. Man. Got a bum knee and a cold. What the hell? All right. Let's see. What was the other thing I wanted to do? Doobie. Where were you? Yeah, I mean, all right. Those are those problems. Okay. 3-4. I think I just barely started grading 3-4. So I haven't run across a lot of stuff yet. Yeah, so I'm not sure what to do there. Anything else that's come to mind while I was doing that as a question before we get into chapter 4 stuff? Okay. Not hearing anybody or seeing anything. You guys do know how to private chat me, right? Just in case. Oh,
Yeah.
good. All right. Sorry. The only people I could see weren't moving, and I thought, holy shit, how long has my Wi-Fi been down? Okay. So again, like I said, if you have something and you're kind of shy or something, you can just private chat me a question. So the last thing we did, we talked about inverse functions. We talked about what they look like if you graph them. Did we finish that sheet I had put up here? Yeah, we did this. Let me see. Did we do? Yeah, we finished this. Yeah. This sheet here. Let me show it to you real quick. I'm pretty sure you remember this sheet yesterday.
Yeah, we finished it.
All right. So that counts as extra practice with that stuff. Okay, so I could finally get my way into chapter 4 unless anybody has a question. Actually, let me do this. Somebody asked me a question earlier about a problem from section 3.5. Let's do another one of those together. A problem from that one section that I was talking about earlier. Here, I'll share this. This stuff here. So let's do one that I didn't assign. Let's try number 71. So if you want to write that down, I'll put that up on the board too. Oh, somebody's chatting at me. Oh, okay. I understand. Okay. Trust me. I understand. Oh, I'm sorry, Joshua. Let me write it up on the board. Okay, Chair. Get over there. This is number 71 in section 3.5. Okay, so let me write this up here. Somebody's asking me to do 3.4 number 90. So I'll look at that one next. All right. What's the basic shape of this going to be? Forget about all the, oh, can you see everything?
It's going to be a V.
There we go. We'll do this. Yeah, it's going to be a V. And now push that a little bit more. It's got a negative there, so it's going to be a V that opens down, right? I can't do that.
Right,
V
yeah.
opens down. Okay. Oh, okay. Now we're getting too specific, but at least I know it's going to be a V. And I notice it's going to open down. That's all I need to know for right now. So I know that ahead of time. What are the 3 shifts? Somebody started listing them for me. Which shift do I want to do last?
Oh, the plus 3.
It's actually 4. This will be interesting. Yeah. So the plus 3 tells me to do what?
Move it up by 3.
I like it. So let's see. Now let's list the other 3 things that are happening. What's going to happen with this dude?
To the right by 4.
Yes, right. 4. And then this here. And again, I'm not. Well, let's see what you guys say. What is that 2 going to do?
Vertical.
All right, stretch. I like it. Stretch by a factor of 2. You can even say, what I call it is amplify. I call that an amplifier. It amplifies by a factor of 2. It doubles all my outputs, which stretches it. Stretch up 2. But I should say like it's stretched vertically by a factor of 2. I got no room for my graph now. Shit. And then the last thing it does, I'm sorry, second to last thing is flip. Flip it over what?
The x-axis.
X-axis, kick ass. Like it. All right. Can you guys copy that down for me, and then I'm going to erase them, and you're going to help me remember them? Because I need more room for this graph. Okay. I think you guys have them. Yes?
Yes.
Okay, somebody does. So, let me see. Sure. What I always do the scale sucks. But this is why you want to get some graph paper. Oh, and I can't count. Apparently, that's a really big problem. Might have to retire sooner than I thought. Somebody got offended because they can't count and left. All right. So what I do is I'm going to graph what I call the base function. But I'm going to graph it with dotted lines, right? Dashed line. Oh, somebody's asking me, why is this a stretch? If it's inside with the X, if there was a 2 right there, it would compress it. Because it does the opposite of what it looks. This does exactly what it looks like, twice as big. So it's going to stretch it. It's going to go up twice as fast. So I guess in a weird way that's a compression, but it's a stretch. You're stretching it up. Makes sense? Makes sense. Okay, thank you. Okay. You might be just saying that, so I have to shut up. I understand. So my base graph looks like it goes through 0, 0, 1, 1, negative 1, and 1. So those are my 3, Jeff, do what you said you're going to do. Those are my 3 anchor points. And now I can just move those anchor points. Let me make sure you guys can see those anchor points. Those are my 3 anchor points for the base graph. Is everybody with me? So what I've just graphed It has nothing to do with this except that's the shape that I'm going to move around. So then I just start moving it around. So the first thing that we listed was to move it right 4, right? So I'm going to take this one, 1, 2, 3, 4. This one's going to 1, 2, 3, 4. And here's 4. And so that's where it is now. Let me make this bigger so you can see them. So that's where my anchor points have moved for this shift. Then I can double everything. And again, you can do more at once if you want to. I double everything. Double 0 is 0. That's crazy. Double 1 is now 2. That's amazing. And double 1 is now 2. That's amazing. So now it's there. All right, let me stop for a minute. This is where I love my, let me see if you guys are able to handle this word. My anal retentive students. You guys know what that phrase means? So my students that use colored pencils and all that kind of stuff. I mean, if you are that kind of student, I mean, oh, so awesome. So I can tell what the shit's going on. If you don't want to do that, you might want to make more than one graph just so I can follow what the hell's going on, right? Okay, I'm running out of colors myself. So, oh yeah, I got some neat colors. All right, let's see. All right, let's see if those look good. Holy shit, did I just freeze? I'm still standing up there. Are you guys?
Yeah, you're frozen. I thought it was my video, but
Frozen.
yeah, you're frozen.
You can hear me though, right?
Yep.
Apparently.
Yes.
Okay, this is really interesting. Let me share my screen. Let me see if I can unlock myself. Like I'm a extra character on a video game. Have I unlocked Jeff? No, I have not unlocked Jeff. Well, that's good. That's gonna work really well. What the hell? What did I do? All right, let me try to restart my camera. But this is the exciting part. This happens all the freaking time. Let me see what I can do here. Oh, I see what's happened. Okay. I'm a sea of blue now, right?
Yes.
Yeah.
Yep.
All right, so he doesn't want to start up again. Well, this is going to be exciting. Let's see. Hold on, guys. And you're like, that's all we can do, buddy. Why don't you want to start back up? There we go. Start. You don't want to start. No, you don't. All right. You guys talk amongst yourselves for a second here. I'm actually kind of surprised this doesn't happen every day. Don't get ideas, universe. All right. I think that will fix it. Let's find out. I just got to do one more thing. Do. What is that now? What has happened here? There's all kinds of weird shit happening. All right, let me see. This should do it. Please work. Please? Am I back?
Yeah.
Yep.
Yeah. Man, you had a great chance to mess with me there. No, we still don't see anything, Mr. Too late. All right. So we left off with the last thing we did was we doubled. So there's 2 more things left, right? What's the next thing we do?
Flip it.
Flip it, pop it. All right, so if I flip it, I don't know why I'm writing so small. So so this stays here, that's on the mirror. This goes down to -2 now. This goes down to -2 now. So now it's here. And then the last thing I have to do is
Raise it 3.
raise it 3. And this is why you might want multiple graphs, because it's already getting kind of spaghetti-ish here. What do I want the final to be in? Let's put it in fuchsia. Is that what that is? Or is that just pink? Is that right? I don't know what the hell. So if I make everything go up 3, so 1, 2, 3. 1, 2, 3. Yes. And so that's going to go. Where am I at right now? It's Jack. Holy shit and a half, dude. You suck. It's amazing. So I'm pretty sure I should be there. How do I check myself? What point is this?
5.
5?
5, 1.
5, 1. So if I plug a 5 in, I better get a 1 out, or I screwed this pooch on this one, right? So if I put a 5 in, what do I get? 5 minus 4 is 1. Absolute value of 1 is 1. Times negative 2 is negative 2 plus 3 is 1. Right? So that's always nice. If you move it around, pick a point you go through, and make sure it actually works in the equation, because that's the connection. I'm sorry, go ahead.
So instead
Gary,
of doing all that, like moving the points, could you just plug in, like make an X and Y chart and just
That's
to the
point. That's the thing we're doing right now, is we're doing it a different way. And did I have to do every step I did? Couldn't I have done several steps at once? I could have taken this point, moved it over 4, and then flip it, and then move it up 3. And then I could have taken this point. I didn't have to show. I want you to show me some work, obviously, because otherwise you just plug in the calculator and copy it. But you don't have to do every single step that I did. You should be able to do a couple things at once, right? Does that make sense? So it's just the fact that we're not comfortable with this yet. And that's why it seems like an XY table would be quicker. But we have to know how functions move around. One other reason we want to know this is because it then makes sense out of what form do I want a circle equation in, for example, so that it will tell me the center. So that's when I wanted something like this. And then I realize, because I realize I can then see the shifts. I can then see the transformation. So transformations are not just for graphing things, but that's what we do at the beginning, because you want to understand what the transformations are. They are also for what's the optimal form of some function. So it'll tell me more about itself. I want to put it in this form so I can see the center and the radius, right? Does that make sense? A little bit? Not much? You suck, Jeff? Okay. All right, anything else, guys? And yes, it is Droid Camp. All right, okay. I'm trying to remember if there was anything. I think that's the last thing I wanted to talk about from 3. I want to talk about chapter 4 a little bit, at least. What time we got? Okay, I want to let us out a little early, because today has been meetings. I'm over it. All right, so just in case somebody checked in after I said this, the quiz that's for tomorrow has been moved to Wednesday. The quiz that's for tomorrow has been moved to Thursday, in case you missed that earlier. Oh yeah, I forgot. I even wrote it down for myself, didn't I? Is it still there? Yeah, somebody asked me a question. So let's look at 3-4, number 90. Do you guys ever do where you will put something somewhere to remind yourself to do something later? Like, I used to do it all the time. I still do. What sucks is recently I've seen the thing and I went, I have no idea what that's supposed to remind me. Anyway, sorry. Something to look forward to, kids, as you get older. So let's see, number 90. All right. So let me throw this up here. This one here, right? I think is the one. Let me double check here. Make sure I'm remembering. Oh yeah, Jasmine, thank you for reminding me. And yes, I got confirmation. Okay, all right. So let's read through this. The function d of p gives the number of items that will be demanded when the price is p. Do I have any future business people or for some reason I can't say economist, economist. There, hey. Sorry. I was channeling our president. Oh. Yosemite. So if there's any future business people or economists, there it is, out there, then this idea of the price point and how it affects things is very central to the whole idea. So one thing that you affect when you raise or lower a price is the demand for that thing. So if Xbox cost 20, there would be remarkably high demand for them. If they cost $3 million, remarkably low demand. So the production cost is the cost of producing X items. To determine the cost of production when the price is $6. Okay. You would do which of the following? So this is an awesome problem. Notice all of the possibilities are compositions, right? So you're trying to figure out what the cost will be when the price is $6. So C of X is the cost of producing X items, right? And D of P is the number of items that will be demanded. So see the connection there already. D of P is a number of items. C of X is the cost of producing a number of items. Let me let that sink in just a minute, because you gotta see how these things want to connect to each other. So the input for the cost function is a number of items. Is that correct? Do you guys agree? Do you concur? Okay. And the output for D of P is a number of items, right? So what would D of 6 mean?
You mean the demand at the price of $6?
Be more specific. Don't just say demand. Be more specific. What the output of a demand is what? And then
the number of items.
Good. D of 6, that expression, D of 6, is the number of items that will be demanded when the price is $6. And of course, if you're a business, what's the most efficient way to run your business? The most efficient. What are you always running for? Do you want to make more items than you will sell? Do you want that to happen? If you ran a bakery, do you want to bake more things than you will sell? No. You want to try to hit that sweet spot, which is why so many bakeries run out of stuff early, because they undershot their sweet spot. They're like, all right. And that's why they sell more tickets for a plane than people you can fit on the plane. Okay. I don't know if this is helping out at all. You guys kind of semi with me right now? So what did I just do? What did I do? I did a unit analysis. I just stopped to think, what do those functions give me? And then I can think, how do they connect then? So I'm actually not going to say anything else besides what I've already said. So D of 6 gives you the number of items you would make. That do not give too much away. The number of items that would be demanded if the price was set at $6. And it's asking you, what's the production cost when the price is set at $6? So, and the input for the production cost is a number of items. And that's all I'm going to say. That's it. That's all I'm going to say. Hopefully that's enough. That's more than you had, I think. Is that okay? I mean, at least you got some more stuff to chew on for a while.
Oh, I didn't even get boba.
All right, give me a second. Mute the shit out of everybody. What the hell is that? Oh, okay. So I got confirmation that that's enough for now. Okay. So last thing for today. I just want to talk about chapter 4 a little bit. You pull it up here. There's only 2 sections in chapter 4, and they really need to be relatively simple. So they really are just linear functions, equations of lines, right? There's not that much to this chapter. And who's unmuted? Let me mute. Let me see. When I'm sharing my screen, I have no idea how to do that. Oh, there it is. No. Ugh. I don't know. Somebody's unmuted. Can everybody mute yourselves, please? Unless you're about to ask a question. All right, I think I found the. Okay. So it really is just about slope. It really is just about rate of change is slope. I mean, this needs to be, that looks evil. This needs to be semi-simple. There's your mx plus b. They make a big deal out of it. It's not a big deal. And hopefully you guys are aware of seeing a slope in a table, right? If my t changes by 1 and my d changes by 83, the slope, what would the slope of this function be? Amber said something, but she's muted.
83.
83. Yeah, it's the change in the outputs over the change in the inputs. Right? Okay. I like it. So, unfortunately, a lot of us are very far away from being done with 3. So, I mean, chapter 3 is your priority right now, especially considering the quiz is Thursday. I'm going to try to catch up on grading. I really am. Because I'll feel better if I've looked at most everything before you take the quiz. But you do need to try to get to 4 just so you can try it out and see what specific questions you have. You know they're going to have a couple of freaky ones. But for the most part, this is stuff you desperately should know already, how to calculate the slope of a line. See, they make a big deal out of it. Hopefully it's not a big deal for us. If it is, it's okay. You can still ask questions. I don't want to make you feel like I'm not going to answer questions about it. Let's see. Is there anything interesting in here? No. And I hope you understand when I say interesting, I mean something that might be new or something that might be a little weird. So look, for example, let me see. Okay. Look at this one. I kind of like the way they present it, but it is still an old question. So if you have a linear function with f of 2 is negative 11, f of 4 is negative 25, can you guys write the equation for it? Do it. I can write that equation with 3 points. I can write that equation with 2. If anybody's stuck on what to do, I can give a little hint. Oh. All right. There you go. There you go. See, somebody's privately chatting a question to me. That's how that works. That's kicks ass. So for the benefit of everybody, if you're having any trouble with this and you're not asking, does this problem give me any points to work with?
Yes.
Yes. What are they?
2, negative 11, and 4, negative 25.
Kick ass, right? Because I can see the input, output, input, output. I can write the 2 points. Now it becomes a lot more of a, algebra, straight up algebra problem where what do you have to find? 2 things.
Slope?
The slope between those 2 points, and then you could either use the point. Say again. Yeah, the y-intercept, I love it. So I'm very curious what methods you guys use. There's 2 main methods to do this. One method is to use the longer equation of a line, y minus y1 equals m times x minus x1. The other way is to solve for b, which once we're at this level, we should start gravitating towards that. So I'll show you how to do that way. Has anybody got the slope yet?
7.
7.
I got -7.
I'm going to get -7 also. You got to be really careful. That's why the formula has little 2 and 1. So if you do this minus this, you must do this minus this. Or if you do this minus this, you must do this minus this. You have to go the same way, or else you get the opposite sign slope. Cool? Does that make sense to everybody?
Yeah.
I mean, if you ever wondered why the shit do they have a little 2 and a little 1 there, it's really just to show you that you got to do it the same order. So you don't have the wrong, what do you call it? The wrong sign. There it is. Yeah, so you get -14 over 2, -7. So you could do this. Does this look familiar to anybody? Because I got the slope, and I've got 2 points. I could pick one and put the x piece there and the y piece there. So if I do that real quick, let me pick this one. All right, so I get y plus 11 equals -7x plus 14. I subtract 11. I get y equal -7x plus 3. Did anybody else get that same answer? Oh, shit. Can you see that still?
Yeah, I got that.
All right. So at least I know if I'm wrong, I got somebody else with me.
I got that answer, but I did it the other
Am
way.
I still sharing this
All
thing?
for B.
There we go. Is that better? God. Somebody remind me if I'm still sharing something that's I can't see shit then. I'm sorry, say it again.
I got the same answer, but I solved for B.
I love it. So let's try that one. So another way is to say, here's this. I already know what x and y are. There's two situations that I know what m is. So let me pick. Let's pick this one this time. So
Yeah,
if I
go
put
up a little bit on the camera.
sorry.
The camera's a little low.
Thanks. -25 equals what was it? -7 times 4 plus b, and then you can solve for b. -28 add 28, you get 3. Same thing. Now, if I want to be really, really honest, I don't do either one of those things, personally. Either one of those things is great. So what I do is I'll say y equals -7x. I know that's part of the answer, don't I? And then I just look. All right, -7 times 2 is -14. I got to add 3 to make it -11. So I'm done. So I just bypass a lot of bullshit. But, you know, you don't have to do that either. You could do this way, you can do that way. You could do that way too if that made sense. I mean, trust me, if you do math for a long enough time, you make a lot of shortcuts. Because, you know, it's a little tiring after a while. Wow, okay, I like that. I got a wow from somebody. Cool, all right. That's, I think that's a decent place to stop. So you gotta, so definitely focus on chapter 3. I hopefully this makes you feel better about chapter 4. That homework should be decently simple. So it's something to look forward to. And come ready tomorrow with questions from chapter 3 so we can be ready for that quiz the next day. Otherwise, I'm going to say class is officially over, and you can hang out if you have any other questions you want to ask. Just let me know.
Thank you.
Thank
See you
you.
tomorrow.
Bye-bye.
Bye, students.
Mhm.
I like the little boxes of like bubbles as people leave. Everybody else all right? You guys all right? Okay. I don't see any questions, so I'm going to leave. Yes? Okay. Are you good? You got a question?
I have a
Yeah,
question. I think I messed up on 12 again. I know you showed us, and like I thought I had it right, but then I just looked, and he said that I did it wrong, and now I tried to redo it, and then it looks worse than the first time.
12, which section?
Sorry, 3.3.
3. Number 12. Let's see. Oh, yeah.
I
Okay.
know you showed that one. I don't
So-
know what I did wrong, basically.
Well, you know the problem idea was a different one. Problem idea was 11, right?
hmm
Okay.
But okay,
So tell me, what did you get? So you did B of 1 plus H, right?
yes,
Okay, good.
and I
'Cause you
got
have
yeah, and so for that part, I got 1 over H plus 4
good. And then
Okay.
B of 1,
is 1 over 4.
1 over 4. Good. So you got 1 over H plus 4
hmm
minus 1 over 4. That's on the top. You want the
Mhm.
difference in the outputs divided by 1 plus H minus 1, the difference in the inputs.
Yeah.
Okay, good. So now on the top, you do exactly what we did. You give each of them the other one's denominator because that's what they're missing relative to
Mhm.
each other. So 1 over H plus 4 gets a 4,
hmm
top, right?
Yes.
And 1 over 4 gets an H plus 4, top and bottom.
Yes. So then it becomes 4 minus H plus 4 over 4H plus 4. Or
No,
4
over,
times H plus 4. So,
over 4 times H plus 4, right? Yes.
yes, sorry.
So on the top, when you said minus H plus 4 is in parentheses, yes? No.
No.
And you know they should be because you're subtracting that whole thing, right? So you're at the point,
hmm
you've got this here. So you got, let me see if I can catch up to you again. You got 4 over 4H plus 4
Yes.
minus H plus 4
Yes.
over
Over 4H plus 4.
What are you subtracting from 4? You're subtracting this whole thing.
Yes.
So it should be 4 minus this whole thing. So the 4s will cancel.
So the 4's cancel?
Yeah, because you get 4 minus H minus 4, right? You got a distributed negative.
Oh, okay. That's where I messed up. I keep doing that. I just I do one little thing wrong and it just fucks up everything.
That is all it takes. But it's good when you
Okay.
realize you were really close. I know it's frustrating, but it's better than not understanding a damn thing.
Yeah.
Laura, are you okay?
Hi. No, I actually have a problem. This week I got scheduled this week to work Wednesday and I start at 4, so I won't be able to take the quiz at the time.
Well, you heard me just a minute ago, right? The quiz is on Thursday. I moved the quiz.
Yeah, I did. I wanted to be sure because I have it all written on my calendar and I was worried.
So I just changed it because I realized I'm a little behind in grading stuff and people are a little behind in doing stuff. So I just pushed it Thursday. So that works out.
Okay, perfect. Okay,
Good.
beautiful. Thank you.
And of course, tomorrow's lecture, I'll have it up on YouTube so you can catch up.
Okay, cool. Okay, cool. Thank you. That's all for me.
All right, you're welcome. See you, Laura.
Have a good one, okay?
You too. I'll do it again.
Bye.
So
Okay,
Amber,
thank you for your help. I think I got it.
you're good? Okay.
Yeah. Okay, bye.
All right, I'll see you tomorrow.